Hi everyone, welcome back to Lulumath. This video is on special cases of systems of equations. So if you take a look, we have a system in front of us with our two equations. Our first equation is 4x minus 3y equals 12, and our second equation is 8x minus 6y equals 24. Now, I'm going to solve this using substitution to start off with, okay? Again, you have three methods to choose from. So for substitution, I'm going to isolate a variable in one of my equations. So I'm going to take my top equation, 4x minus 3y equals 12. Just doing a quick scan, it appears that none of these coefficients is going to allow us to avoid fractions. So we're going to deal with fractions, okay? So I'm going to isolate the y. And in order to do that, I would prefer to add 3y to both sides to make the 3y positive. So I end up getting 4x equals 12 plus 3y. Okay, then I would subtract the 12 from both sides, and I would end up getting 4x minus 12 is equal to 3y. Divide everything through by 3, and I end up getting 4 over 3x minus 4 is equal to y. Okay, now what I need to do is I need to take my purple equation, 8x minus 6y equals 24, and instead of y, I'm going to replace the y with this expression right here, this 4/3 x minus 4. So I will go ahead and copy down the rest of the equation. Until I get to y, I'm going to replace it with 4 over 3x minus 4, and then I'm going to copy the rest of my equation down. So I get equals 24. So copy down the 8x, okay, and then I have to distribute this negative 6 to this 4/3 x. Well, let's figure this out. Negative 6, there's an invisible 1, times 4 over 3. This works out to be rather convenient for us because 3 and 6 are both divisible by 3. So 3 divided by 3 is 1, and negative 6 divided by 3 is negative 2. So I can multiply this negative 2 times this 4, and I end up getting a negative 8. And then this one and this one, anything divided by 1 is itself, so I don't have to write that part down. So this ends up becoming minus 8x, okay? Then distribute the negative 6 to the negative 4, and you get positive 24, and that's equal to 24. Well, 8x minus 8x is nothing. You get 0. A lot of people will try to write x down, but if you write x down right here, that means that you have 1x, which is not true because 8 minus 8 is 0. So let's go ahead and erase this piece right here. And because the 8x and the 8x will cancel each other out, I'm not going to write anything down, and I'm just going to copy down this 24. So I get 24 equals 24, which is a true statement. It is true that 24 equals 24, but I don't really see how this is helpful to us because it doesn't tell us what x is and it doesn't tell us what y is. So things are a little strange here. So what I'm going to do now is I'm just going to try to solve this using elimination instead and see what happens if I solve this using elimination. Okay, so let's copy down this 4x minus 3y equals 12. And then I will copy down this 8x minus 6y equals 24. Okay, and I will try to cancel out my x's here. So I'm going to look for the LCD or LCM of 4. Right here is my coefficient for this x, and this coefficient is 8. So the LCM of 4 and 8 is 8 because multiples of 4 would be 4, 8, 12, and 8 is a multiple of itself, okay? So in order to do this, I'm just going to multiply the top equation by 2 to get the x's to match up. But remember, I want one positive and one negative. So since this 8x is positive, I'm going to multiply everything through by negative 2 to make this 8x negative. So 2 times negative 4x is negative 8x. Sorry, negative 2 times positive 4x is negative 8x. Negative 2 times negative 3y is positive 6y. And then negative 2 times 12 is negative 24. Okay, the purple equation stays exactly the same. So I'll get 8x minus 6y equals 24. Well, I need to add these two guys together. So when I add them together, negative 8x and positive 8x cancel out to give me 0. Positive 6y and negative 6y cancel out to give me 0. But I have to write something down. If both terms in my left side of my equation cancel out, I have to put some number down, and they cancel out to give me 0. I have nothing left over. And then negative 24 and positive 24 are also going to add up to give you 0. So I get to something very similar to what we have right here. 24 equals 24, 0 equals 0. This is also a true statement. So what is happening? I think getting a visual picture of what's going on is going to help us to understand why we end up getting these very strange solutions to this system of equations. So I'm going to take Desmos and I'm going to write both of these equations into Desmos. So our first equation is 4x minus 3y equals 12. And our second equation is 8x minus 6y is equal to 24. And if you notice, I have my red equation is this first one up here, and it's graphed out as shown. And then once I turn on the blue equation and I click on it, the blue equation is exactly on top of my red equation. Well, why is this happening? Because they're literally the exact same equation. All I'm doing is I am doubling this top equation right here, multiplying it by 2, and if I do it to everybody inside of here, then it's the exact same equation. So this is pretty much saying that whatever works for the blue equation right here will also work for the purple equation. Let's look back at our lines and understand this a little bit more. Well, remember, whenever we have a system of equations, where the lines intersect is always our solution. So for example, I'm just going to change this to a plus 6y. They intersect at 3, 0, so that is our solution. However, it's not plus 6y, it's minus 6y. And that means that they intersect everywhere on the line. Well, a line has infinite points, right? No matter where I am on the line, there's always another point that I can look at. So because there are infinite points on my line, this system of equations has infinite solutions. In summary, since both equations in the system are equivalent, they intersect everywhere along the line. Therefore, any point on the line is a solution, making the system have infinite solutions. All right, let's look at a different type of case. So we have this 5x minus 2y equals 14 is our first equation, and our second equation is y minus 6 equals 5 over 2x. So I'm going to start with substitution again. And this time, because this has a y right here, I'm going to make my life easier, and I'm going to isolate the y in the purple equation. So in order to do that, I would just add the 6 to both sides. The 6's cancel, and I get y equals 5 over 2x plus 6. Now I'm going to take my blue equation, 5x minus 2y equals 14, and every time I see a y, I'm going to replace it with this 5 over 2x plus 6. So I'm going to copy down the 5x minus 2 times 5 over 2x plus 6, and then I'm going to say equals 14. Okay, so I'm going to distribute this negative 2 through. I'll copy down this 5x first. So when I distribute this negative 2 to this 5 over 2x, the 2's will cancel each other out because it's negative 2 over 1 times 5 over 2x. So this 2 and this 2 both become 1's. So I get negative 1 times 5 times x, which is negative 5x, okay? And then I'll distribute the negative 2 to the 6, so I get negative 12 equals 14. Well, here we end up getting 5x minus 5x, which is no x. So we don't write any x's down at all. So they cancel each other out, and I'm only left over with negative 12 equals 14, which is not true, ever. So again, I'm faced with a situation where things feel a little strange. So let's go ahead and try to use elimination this time, and we're going to see what happens when we do elimination. Okay, so my first equation is 5x minus 2y equals 14, and my second equation is y minus 6 equals 5 over 2x. Well, to make things a little bit simpler, I'm going to get rid of the fractions in my purple equation here. So my common denominator is 2, so I'm just going to go through and multiply everything through by 2. So 2 times y is 2y. 2 times negative 6 is negative 12, and then 2 times 5 over 2x is what we did here, except this time it's positive 2 instead of negative 2. So I get positive 5x, okay? Um, Now, if you look at the blue equation that we have up here, 5x minus 2y equals 14, we have it so that the x's and the y's are on the left side, and then the constant is on the right side. So I'm going to rearrange this purple equation right here, so that way I can put the x's and the y's on the left side, just so it matches and lines up with the blue equation, and then we're going to put the constant over onto the right side. So I'm going to subtract 5x to put the x's and the y's on the same side. Because the x's went first in my blue equation, I'm going to write this minus 5x here first, okay? So negative 5x, this is a positive 2y, so plus 2y, minus 12 equals 0. Now I'm going to get the constants on my right side, so I get negative 5x plus 2y equals 12. Okay, now I'm going to take this blue equation that we have and I'm going to copy it down. Minus 2y equals 14. So let's see what ends up happening here. Well, we know that negative 5x and positive 5x is 0, so those will cancel out. We also know that 2y minus 2y is also 0, so we have nothing left on the left side. So I'm going to say I have to fill some number in here. So we're going to say 0 equals, and then 12 plus 14 here is 26. So 0 can never equal 26. So this statement is also never true. So again, what's going on? What's happening? Let's go ahead and take our two equations that we have here, and let's graph them out in Desmos and see if a visualization will help us out. So our first equation is 5x minus 2y equals 14. And our second equation is y minus 6 equals 5 over 2x. Okay? And if you notice that the two lines, when you graph them out, are parallel. They're exactly parallel to each other. Well, parallel lines will never intersect. And in order to have a solution to a system of equations, you have to have an intersection point. So this is why we keep ending up with numbers that will never be allowed to be equal to each other, because there is never going to be a solution to the system of equations. So let's talk about this algebraically just a little bit more. So if you notice right here, when we isolated the y in the purple equation, we ended up getting y equals 5 over 2x plus 6. I would like to also isolate the y in our blue equation right here. So our blue equation is 5x minus 2y equals 14. Okay, I'm going to add 2y to both sides to make my y positive. So I end up getting 5x equals 14 plus 2y. Then I'm going to subtract the 14 from both sides, and you end up getting 5x minus 14 equals 2y. Divide everything by 2, and I would end up getting 5 over 2x minus 7 equals y. Well, that's one of my equations, and we earlier realized that the other equation, the purple equation, is y equals 5 over 2x plus 6, which means that they have the same slopes. So if you notice right here, they have the same slopes, but they have different y-intercepts, which is why we ended up getting parallel lines. So this information here is extremely important. Since the lines are parallel, they will never intersect. Therefore, this system has no solution. So I just want to say, if we get to a point in our solution where we get two equal numbers, that means that the equations are exactly the same. Okay, so here 24 will always equal 24 and 0 will always equal 0. So that means that the equations are equivalent and that there are going to be infinite solutions. Any point on the line will be a solution. However, if we get to a point where we get two completely unequal numbers, that means that the equations will never have a solution. They'll never work. So that means that the lines are parallel, which means that the system has no solution. All right, thank you for watching this video. If you have any questions, please let me know in the comments below or at lulumath.com. Um, also visit lulumath.com if you'd like a copy of the notes for this video. You can find a blank version or a filled in version. Please share this video and subscribe, and hope to catch you soon. See you next time. Bye.